Hello, today we're going to be talking about transformations of linear functions, and we're going to be using a key to kind of help us. We're going to be looking at our parent function and how we move that parent function up, down, left, and right, and sometimes with a reflection. So if I have a function that has moved up, then I'm going to say take my function and add to it, and we're just going to use the letter k, kind of like the y-intercept. If I have a function and it moves down, I'm going to do minus k. And keep in mind, these are just standing in for numbers. If I move my function left or right, if I move it left, so I move it this way, I have to think opposite. What would it take for me to get back to the origin? I would have to move right. So I would say f of x plus h if I'm moving left, and then f of x minus h if I'm moving right. Now, what about a reflection? A reflection, if I'm reflecting over the y-axis, then what I'm going to do is whatever my x is, I'm going to take that and make it its opposite. So this is the reflection over y. And if I'm reflecting over x, I'm going to basically take the whole function and flip it over. So that would be the reflection over x. Now, question number 1 says, find g of x where g of x is a translation 10 units up of f of x equals x. So f of x equals x is the same as saying y equals x. It's our parent function. And we're saying take that function and we want you to move it up 10. So I would just take my function and I would add 10. So g of x would be equal to x plus 10. Let's look at number 2. Find g of x where g of x is a reflection across the y-axis of f of x equals x. So I've got f of x equals x, and this time we're told it's a reflection across the y-axis. So what we're going to do is we're going to use this as a base, or this as a guide as to what we do. So we're going to make x its opposite. So where I see x, instead I'm going to write g of x is now equal to the opposite of x, or negative x. Number 3, find g of x where g of x is a translation 2 units down of f of x equals x. So g of x, I'm simply just moving my function down 2. So that would just be minus 2. So x minus 2. Number 4, we've got find g of x where g of x is a translation 2 units left of f of x is equal to x. So we come over here. Now they said move, that the function moved left. So I'm going to write my answer opposite of that. So instead I would say f of x, and I'm moving left. So instead of using subtraction for left, we're going to use addition instead. And actually this is going to be, we move 2 units, so let's make this a 2. So g of x then would be equal to x plus 2. Number 5, we've got find g of x where g of x is a reflection across the x-axis of f of x equals x. So f of x equals x is again the parent function, or you can say is y equals x. We're doing a reflection across the x-axis, so we're going to use this guide. So we're doing the opposite of the function equals x. Now, what I'm saying is take this entire function and multiply it by -1. So g of x then becomes -x. Number 6, find g of x, where g of x is a translation 10 units right of f of x equals x. So again, it's 10 units right. So to write it as its opposite means I'm going to use minus. So I've got f of x minus 10 is equal to x, and where I see x, I'm going to put in its place x minus 10. So our new function is g of x is equal to x minus 10. Number 7, we've got find g of x, where g of x is a translation 8 units right of f of x equals x. So again, we're going 8 units to the right, so I'm going to write it as opposite. X minus 8 equals x, and where I see x, instead of writing x, I'm going to write x minus 8. So our new function g of x equals x minus 8 would be our answer. All right, let's do a few more. We've got number 8. It says find g of x, where g of x is a translation 6 units right of f of x equals x. So again, we're going right. So we would write that the opposite, minus 6 equals x. And where I see x, just like I replaced x with x minus 6 here, my new function, I replace x with x minus 6. Okay, and then number 9, we've got find g of x, where g of x is a translation 5 units up of f of x equals x. So it's translated up, where that means that our g of x is just x plus 5. Now guys, I want to tell you while we're waiting for our next problem, that if you learn the rules of this is how you transform any function. All functions and transformations work this way. If it's on the x-axis, you always write the opposite of how it moves. If it's on the y-axis, you write exactly how it moves. So let's look at number 10, and I think I'll make this the last one. Find g of x, where g of x is a translation 2 units right of f of x equals -6x minus 7. So I've got f of x is equal to -6x minus 7. And I'm told that my function is going to move to the right. So here, if I'm moving to the right, I'm going to write the opposite of that. So x minus 2 equals -6x minus 7. Now, again, I replaced x with x minus 2. So now, when I'm solving my g of x function, instead of writing x, I'm going to write x minus 2 in its place. So we've got x minus 2 minus 7. So we've got -6x because I'm distributing the 6 to both terms. -6 times -2 is +12 minus 7. So we're going to combine like terms right here. We've got -6x plus 5. So that's what happens when we shift our function 2 units to the right. This is where the new line lies on the coordinate plane. So -6x plus 5. Now what happens when we have to move it down? Okay, so we've got find g of x, where g of x is a translation 8 units down of f of x equals 4x plus 7. So 4x plus 7, and we're going to move the function 8 units down. Now we're not moving it left or right, so we really don't need to do anything right here. What we need to do is if we're moving this 8 units down, then our g of x function is going to be 4x plus 7 minus 8 and combine like terms. So 4x minus 1. And that makes sense because if I move 8 units down from 7, I end up at negative 1. So we've got 4x minus 1. All right, I think I am going to stop right here. You go ahead, take it to 100.